Welcome to FPV Lesson 1, Intro to First-Person View Drones. So we're going to get started with kind of broad overview of what FPV is, some terms, some definitions, and then after that we're going to deep dive into the actual drones themselves. So, agenda for today. Terms, definitions, key components. Like I said, the deep dive, we're going to get you where to begin, what do you start with. We'll get to a little bit of simulators. Big thing here is going to be expectation management. And then what should you do first? So, terms and definitions. So, FPV stands for first-person view drones. Okay? It is a drone, just like you see here on the back wall, that you observe with either goggles or on a screen. Most people use goggles, and you're staring at what the camera is doing. Okay? The frame itself, as you can see in the bottom left hand of the screen, is going to be that carbon fiber piece, right? So there's a lot of different components, which we'll get into later, but as a whole, it's a frame. The flight controller. This can be your CPU, right? So the brain's the operation. It also has some sensors, so gyros, barometric sometimes. So that's your flight controller. It's doing all the calculations. It's telling the ESC, which is the electric speed controller, what to do with the motor, right? So ESC is the thing that takes the power from the battery and powers all your peripherals, as well as sends voltage to your motors. It does that through something called MOSFETs, which we'll get into. But the combination of those two, so your flight controller and your ESC, is going to be what's called your stack. Okay. Next, we've got video transmitter. Okay, so there's a bunch of different video transmitters. We will get into that, I promise. But generally speaking, that's the thing that takes the camera, which we talked about, that first-person view camera, and then transmits it over the air to your goggles. It can do this through the flight controller or directly through the video transmit system itself. Again, there's many types. We'll get into them. Next, the radio module. So your radio module is going to be the thing that receives your inputs from your controller, right? So I am sending commands, we'll say, from the ground to the drone. This is the thing that receives those and then tells the flight controller what those inputs are. And then finally, you have your radio controller. This is a component that we use as pilots to control aircraft movements. And because of switches, you can control other peripherals on board. Okay, motors, right? So we'll deep dive into motors, but in general, these are the electric motor that rotates the drone. Okay. When you mine it, you might have heard drone sizes, right? So you might have heard, it's a 5-inch drone, it's a 7-inch drone, it's a 12. Okay. A 5-inch drone just means that one of these props right here, okay, is nominally 5 inches. Okay, so the frame itself is not 5 inches. It's actually a prop. If you have a 7-inch drone, it's gonna be larger. If you have a 3-inch drone, it's gonna be smaller. What a whoop is basically just like on the picture here. It's when this is contained by a frame. So this is technically a frame. Okay, so this white part is the frame. But each of this surrounding kind of prop guards make it a whoop. And then flight mode. Okay, so flight mode is the relationship between the control inputs and what the drone does relative to the knowledge that the flight controller has. We'll get into those. Generally, there's going to be 3: acro or air, level, and horizon. Most of your time will be spent in acro or level or angle. So, deep dive into the frame. Okay, this is a drone that has a lot of extra straps on it, so GoPro does. But you've got your arms, which are the arms that hold the motors. You've got little standoffs right here. Okay, you have typically you have a top plate and a bottom plate. Okay, this drone's a little bit different, but generally speaking, bottom plate, top plate. And then you have stack screws. Okay, so they're hard to see. You can see them on the image here, but stack screws are what holds your stack, which, if you remember from just a second ago, flight controller, ESC, smushed together, stack. Flight controllers. So this is a flight controller. The flight controller, its entire job is to do the calculations and receive the data from all the peripherals and translate that into actions or things. I know that's pretty vague, but generally speaking, if I put an ESC to this, which little ESC plug right there. If I put an ESC, if I attach an ESC to this, the flight controller is in charge of telling the ESC when to send power to each individual mode. It does this very, very fast. If I have a video transmit system that is plugged into the flight controller, it's responsible for sending camera data from the camera through the flight controller to the video transmit system. Same thing with GPS. It does a lot. We'll get into some of the stuff that I talked about a little bit later, but just flight controller, great. Each solder pad on here is going to have a specific purpose, generally speaking. So there's a thing. So 5 volt means it's regulated 5 volts from the ESC to whatever that purpose is. Okay. So if I have an HD system, an HD video transmitter that requires 10 volts, and I start it to a 5 volt pad, as that 5 volt regulator regulates it at 5 volts, it's not going to power that HD video system. Okay. If ground is ground, there's also these things called UARTs. UARTs are, think of it like a USB. Okay. So what a UART does is it stands for Universal Asynchronous Receiver Transmitter, basically a hardware protocol. You can read about it on the screen, do your research on it. There's some things to consider with UART. Okay, so generally speaking, a UART has a TX and an RX. Okay, this is when it's simplex. You have simplex, which means data can only be sent one direction only. Okay, so from the flight controller or to the flight controller. You have half duplex, which means that it can send and receive, but it can't do it at the same time. And you have full duplex, which means that it can send and receive at the same time. Okay, if you look at the screen here, you got a bunch of UARTs, you got a bunch of stuff on the screen. Okay, this is from the F7 Brave by Rotor Riot. I just use an example because it has plugs and solder pads. But if you look on the left-hand side where it says 5 volt right, ground. Okay, then you have something called VI. VI means video in. So it's an analog system. That's the camera video in. Okay. Then you have CC, which means camera control. We won't get into that right now, but just know you can control your camera from the flight controller. If you look at the ESC on the top part, you have the ESC 4, 3, 2, 1, UART RX. Okay. And then you have ADC current, ground, and VN. VN in this case means voltage in, means it's the full voltage of the battery. Sometimes it's called VBAC. If you ADC current is the sensor that tells basically the drone how much current is flowing, as well as voltage. So GPS, we're not going to get into that, but you can see there's UART 3, TX, and RX. If you look at where it says RX, okay, so this is for this flight controller specifically designed for your radio receive. Okay, so your radio receive has a TX and RX as well. Flight controllers, it gets a little weird. So you want to take a TX from, we'll say, your peripheral. Okay, so in this case, you have, this is not a radio receive. Let's say it's a radio receive. So on the radio receive, I'm going to have TX and RX. On the flight controller, I'm going to have TX and RX. I need to swap them. Okay, so TX from the radio receive goes to RX on the flight controller, and RX from the radio receive goes to TX on the flight. Okay, so they're swapped. Think of it like I am sending something from the radio receive and it has to be received, or transmitting and it has to be received, or I'm receiving something that has to be transmitted. Okay, so they just swap. I recommend figuring out a color code whenever you're wiring these. Some people use like RX is always green, or TX is always white, just so that it doesn't confuse you. ESC. ESC takes power from the battery and puts it in the flight controller, and also uses that power from the motor. Okay. Keep in mind that it has to get a signal from the flight controller in order to power those motors, which we'll get into a little bit later. But generally, just think of it as a power distributor. Okay. Right now, most flight controllers that you're going to get are called 4-in-1. Okay. What that means is there's 4 separate ESCs within that one little package. Previously, kind of when FPV was just getting started, there were, and you'll still see it with quadcopters, you'll have you have 4 motors, you have 4 ESCs. and they're typically like actually about this size, about this size, and you have wires running in each direction. Okay, so what they've recently done is, I say recently, they've been around for years, but anyway, 4-in-1 just means 4 ESCs in that one. You can also have an AIO board, so an all-in board. These are going to be more common. They're starting to come around for larger builds, but basically this is flight controller, your ESC, your video transmitter, and your radio receiver. Very small, but if one of those goes bad, then the whole thing's messed up. Video transmit system. Okay, so video transmit system does exactly that. It takes the video feed either from the flight controller or from the camera directly, sends it over the air, and it's received by your goggles. Okay? There's HD and there's analog. Okay? HD works, generally speaking, by sending, except for HD0, but by sending pictures across the air. Okay? And then when your video transmitter stops receiving those signals, you just get the last image. Okay? Analog works kind of like old school analog TV, where you tune into a certain frequency and it's open broadcast. What it means you don't have to bind the goggles to the video transmit system, but it also means anybody can view them, which can be good. Okay. So for the analog, so this drone is a racing drone. It's got a little beat up, that's fine. It's got an analog camera, which goes into the flight controller. Then from the flight controller, it goes to a video transmit system, and then finally out through this antenna. Okay. For HD, this is a walk snail. This is a camera that the wire goes directly to the video transmit system, which is this thing in the back here, okay, of these antennas. And the only interaction that I have with the flight controller is just the video transmit system power, because the power goes from ESC to the flight controller to the 10-volt pad to the video transmit system, as well as some controls. Okay? So, but generally it's self-contained. If you want to deep dive into this, there's the link you can see is some good reading. But generally speaking, HD0 is going to be most common in racing. It's somewhat of a hybrid between analog. Walk snail is good middle ground for cost and kind of distance or range, we'll say. DJI is very clear, but has some software constraints in terms of range and geolocation sometimes. And OpenIPC is pretty new, but basically that is an open source HD system. So, radio receive system. They're small peripherals that solder directly to your flight controller and tell the flight controller what inputs are being received from the radio, okay, or the radio controller. Most commonly, this protocol is going to be something called ERLS or Express LRS. Okay, it's made by a Swedish company. It's open source, and there's a lot of different radio receive systems that have it. Okay? Express LRS generally runs on 2.4. There is a 915 version. Let's talk about megahertz. We're going to get into radio propagation and radio frequencies for FPV in a later course, but most commonly it's going to be 2.4. Just make sure when you're buying something, you have 2.4 on your drone and 915 on radio. Okay. Other protocols too exist. So TBS Crossfire is really popular. Ghost. TBS Crossfire is made by a company called Team Black Sheep. It operates mainly at 915. Ghost operates at 2.4. It's made by Immersion RC. There are some other protocols like FreeSky. So if you get a controller and it says 4-in-1, it doesn't have ERLS on it. It has some of these older models. I don't recommend the 4-in-1 unless you're specifically flying that, because even though it's 4-in-1, it's a lot easier these days to get ERLS receivers than it is like the FreeSky and the other stuff. Okay, they must match the protocol. So controllers. I know on your screen is something different. That's called Radio Master Pocket. It's my recommended one. We'll get to it in a second. This is a Radio Master Boxer. I just want to show you something. So you've got your sticks, which are right here. So you've got your left stick and your right stick. We'll get to what each one does here in a moment. But you've got switches, and on controllers, you have a momentary switch, which, for example, this one, I press in and I release. It activates when it's down. It stops activating when it's released. Okay. Then you have 2 position. So on, off, or up, down. Then you have 3 position, which is like up, middle, down. You also have dials. Dials are generally going to be for your trim settings, for like fixed wing stuff. For FPV, I don't use a lot of switches. I basically use an arm and disarm. I use a flight mode switch. So we'll say at the top I have, it's an acro mode always, because standardly you want to start with your switches away from you. But at the top I'll have like acro, middle horizon, bottom angle. Then also have like flip over after crash on momentary switch. That's just my preferences. But in total, I only use a handful of switches. So if you're looking to upgrade, if you're looking to get a different controller than I recommend, which is fine, just know that you're only going to need like 3 switches. So mode 2. Mode 2 is the setup of the controller and which sticks auto center. So on the left side, I have yaw and I have throttle. On the right side, I have pitch and I have roll. Okay. Throttle is the only one that doesn't auto center. Everything else auto centers just like an Xbox or a PlayStation controller. But if I have throttle that auto centers, then it's going to be really challenging to have good throttle control, which is one of the most challenging things to get good at within FPV, which we'll go over some tips and tricks and some practice stuff you can do later in another class, but just broad overview of the controls. All right, so motors. So I have a spare motor here, okay? I'm not going to get into like the deep dives of Bell and all the other stuff, but I'm just going to give you, like, if you're looking at motors, try to figure out what all these numbers mean. I'm going to real quick explain to you. So each motor has a series of numbers. Okay? So for example, this is 2808. The example you have on a screen is 2206. What that means is that the diameter, okay, the diameter up here is going to be 22 millimeters. And inside here, there's coils, just like you can see on the screen. That height is going to be, in this case, 8. Okay, so this is a 2808, which means it has a 28 millimeter diameter and a 8 millimeter height of the coils. Okay, then you're going to have a kV rating. So this is a 1500 kV motor. What that means is you get at a certain voltage, you get a certain RPM. Okay? 3-phase motor. So it, for example, on the screen, because I'm not doing public math, you have a 1750 kV motor, and then you have 22.2 volts. At 1750 kV and 22.2 volts, you're going to have a 38,850 RPM. Okay? That's just all that means with motor. Okay? Just want to give that a brief explanation because you're going to see a lot. If on, for example, this whoop, I have, what size are these? So these are 0802s, which means an 08 diameter in terms of millimeter and an 02 height in terms of the coils. And then it's 19,000 kV. So this is spinning very, very fast, but it's not, there's not a lot of torque behind it. You can do some research on there for what motors that you need. 2808, I've used on a 7-inch. All right, thanks for sitting through that. So where do you get started? What do you have to do to fly FPVs and get some eyes in the sky, right? Super simple. You get a controller, you get some batteries, and you get a sim. Okay? For the controller, I recommend the Ready Master Pocket. It's cheapest worth having in my opinion. Get the ERLS version, $65. You need $10 worth of batteries, so get 18650 batteries. Can't go wrong with a high milliamp hour. And then you need liftoff, okay? So liftoff is the best simulator that I recommend for flying and especially learning, because the tutorial, in my opinion, is better than the other ones. Other ones you can get are DRL, Trip, Uncrash. There's a couple other ones here and there, FPV, Skydive, but liftoff, in my opinion, is the best to start. Okay, so less than $100, you can get started in FPV. I do want to briefly talk about expectation. Okay, so FPV isn't like any other drone. It's not like a DJI, it's not like a Skydio, it's not like a Parrot, okay? So it's going to be frustrating at times, just flat out. It is going to piss you off, okay? If it does that, which I have been in that situation myself several times, especially when I'm trying to push myself for practicing for races, step away, take a break, okay? Ultimately, like, you're not having fun, you're not engaged, you're just be slamming your head against a wall or a gate or a tree on some of the maps, okay? Try something different. If you're really struggling on a course, try it different, okay? There will be stuff in the syllabus to help you through this, but generally speaking, if you're getting angry, step away, okay? Come back to it. take a break. It's going to take many hours of sim practice before you fly. In the Lost Drone alone, I have 150 hours, and I still crash. Okay, like all of the guys who you see who are doing these really cool tricks or going really fast on the map, they've crashed a lot before that cool video. Especially the freestyle pilots, they have broken very many GoPros. Okay, it happens. It is part of FPV. Other than that, have fun.